You are moving right now. Not metaphorically, not emotionally, not philosophically. You are moving through the universe at a speed so extreme that if your mind could truly grasp it, your sense of stillness would never feel the same again. But that feeling is an illusion, because at this exact moment you are traveling in multiple directions at once, carried by forces far larger than anything you can see. NASA didn't create this motion. They didn't start it. They didn't control it. They revealed it. Is moving. You may never think of stillness the same way again. Right now, you are not simply sitting. You are not simply resting. You are riding something ancient, vast, and unstoppable. And the most unsettling part is this. You didn't choose the direction. You never did. When we look around, our instincts betray us. Walls don't move. Buildings don't drift. Mountains don't slide past the sky. Everything appears fixed. But space does not care about appearances. NASA's measurements show that motion is layered, like invisible currents flowing through each other. You are moving with the Earth, which is moving around the Sun, which is moving through the Milky Way, which itself is moving toward something we cannot fully see. Each layer adds speed. Each layer adds direction, and none of them stop. Let me slow this down, not to simplify it, but to let the weight of it settle into your mind. Imagine you are floating in darkness. No landmarks, no stars, no reference points. In that darkness, motion becomes meaningless unless something else moves differently than you do. That is how the universe hides its movement from you. You feel still because everything near you is moving with you. But NASA does not measure motion by feeling. It measures motion by light. And light never lies. NASA uses tiny shifts in light called redshift and blue shift to detect motion across unimaginable distances. When something moves away, its light stretches. When it moves toward us, its light compresses. This is how NASA discovered something disturbing. Almost everything we can see is moving, not randomly, not chaotically, but with patterns, directions, flows. And once those patterns are revealed, the universe stops looking like a static place and starts looking like a river. A river you are already inside. Right now, the Earth is spinning beneath you at the equator. That spin reaches about 1,670 kilometers per hour. You don't feel it because the air spins with you. The oceans spin with you. Your body spins with you. The universe is kind enough not to tear you apart, but not kind enough to stop. And that spin is only the beginning, because Earth is also orbiting the Sun at roughly 107,000 kilometers per hour. That means since you started watching this video, you've already traveled farther through space than most cars will in their entire lifetime. And still, that's not even close to the full story, because the Sun itself is not resting at the center of the galaxy. The Sun is moving, dragging Earth, dragging you, dragging every memory you've ever had. NASA calculates that our solar system is racing around the center of the Milky Way at approximately 828,000 kilometers per hour. Let that sink in. Every laugh, every sleep, every quiet moment happened while you were moving at a speed that defies human intuition. And yet, even this is not the final direction, because the Milky Way is not anchored, it too is traveling. The Milky Way is being pulled, not gently, not slowly, but relentlessly, toward a region of space filled with mass we can barely observe. NASA calls it part of a larger phenomenon known as the Great ATTRACTOR. But notice something important. They didn't call it the destination. They called it an ATTRACTOR because we don't know what it truly is, only that it pulls, only that galaxies respond, only that everything nearby is drifting in that direction, including us. If you could zoom out far enough beyond stars, beyond galaxies, beyond clusters, you would see something unsettling. Galaxies are not scattered like dust. They flow like schools of fish, like leaves in water, like whispers carried by gravity. NASA's data shows that hundreds of thousands of galaxies are subtly leaning toward a shared direction, not rushing, not falling, but moving patiently, and patience in the universe is far more powerful than speed. Now here is the question that should quietly disturb you. If everything is moving, what is not? If every reference point is drifting, where is still? The answer is uncomfortable. There is no universal stillness, only relative motion, only comparison, only direction, without destination. Even the universe itself is expanding, not expanding into something, but expanding within itself. Every second, space stretches, distances grow, galaxies slide apart. NASA describes this expansion not as an explosion, but as inflation, a calm, silent, unstoppable widening, which means this: even if every galaxy stopped moving tomorrow, the space between them would still grow. Direction without travel, motion without footsteps. And yet, despite all this movement, to still feel calm, you still feel grounded, you still feel at rest. That is the genius of the universe. It moves you so completely that it never lets you notice. But now that you do notice that yourself, if you are moving through the universe right now and you didn't choose the direction, where are you actually going? The Earth has never been still. Not once. Not when the first oceans formed. Not when the first stars appeared in the sky. Not even now, as you sit quietly, feeling as though nothing is happening. The motion simply learned how to hide itself. NASA did not discover that Earth moves. Humanity has known that for centuries. What NASA revealed is how many directions Earth is moving at the same time, and how little control we have over any of them. Because Earth's journey is not simple. It is layered, it is curved, it is precise, and it is relentless. And once you understand Earth's secret path through space, the ground beneath you will never feel as solid as it once did. Let me begin where motion feels smallest, the spin. Earth rotates once every 24 hours. Our planet completes a full turn around its axis. That single motion defines day and night, light and darkness, waking and sleeping. It feels natural, predictable, but speed hides behind familiarity. At the equator, the surface of Earth is moving at roughly 1,670 kilometers per hour. That means you are already moving faster than the speed of sound simply by existing. You don't hear wind rushing past your ears because the atmosphere is moving with you. You don't feel acceleration because Earth's rotation is smooth, ancient, settled. NASA measures this rotation with extreme precision, down to milliseconds, because even the tiniest change matters. The planet does not spin at exactly the same rate every day. Earth slows and speeds up subtly. Earth WOBLES. Earth shifts, and those tiny changes ripple outward into time itself. Time depends on motion. When Earth rotates slightly slower, days grow longer. When it rotates slightly faster, days shrink. NASA must account for this by adding leap seconds to our clocks. Think about that. The planet you live on is so dynamic that even time must occasionally stop and wait for Earth to catch up. Motion rewriting time. But Earth's spin is only the first layer, a surface motion, a skin-deep illusion of movement. The deeper journey is orbital. Earth does not circle the sun in a perfect loop. It follows an ellipse, slightly stretched, slightly off-center. At its closest point, Earth is about 147 million kilometers from the sun. At its farthest, about 152 million kilometers. That distance changes everything. Seasons are not caused by distance alone, but distance whispers its influence. NASA tracks Earth's orbit with exquisite care, because if Earth drifted too far inward, oceans would boil. Too far outward, ice would consume continents. We live in a narrow corridor of motion, balanced between fire and frost, and we do not steer. Earth orbits the sun at approximately 107,000 kilometers per hour. Let me repeat that quietly. 107,000 kilometers per hour. Every second you watch this Earth travels nearly 30 kilometers through space. Yet the sky appears unchanged, because space is vast enough to swallow. Motion whole. Now imagine something unsettling. Imagine drawing Earth's path through space, not a circle, not a loop, but a spiral. Because while Earth orbits the sun itself is moving, and Earth is being carried along. NASA describes the sun's motion around the center of the Milky Way as a galactic orbit. The sun completes one full lap around the galaxy approximately every 225 to 250 million years. That means since the first dinosaurs walked on Earth, the sun has not even completed one full orbit. We are passengers on a journey that began long before memory and will continue long after. As the sun moves, Earth traces a helical path through space, like a corkscrew, like a ribbon drifting behind a runner, like a thread woven into a larger cosmic fabric. Earth does not return to the same place in space. Each year, it returns only relative to the sun. The universe remembers. NASA simulations show this clearly. If you could step outside the galaxy and watch our solar system move, you would not see circles. You would see a flowing curve, a path that never overlaps, a journey that never repeats. Which means this: the Earth you are on right now has never been here before, not once, and it never will be again. But even this motion is still not the full truth, because the sun's orbit around the Milky Way is not smooth. It oscillates up and down, above and below the galactic plane, like a slow cosmic wave. NASA estimates that the sun passes through the dense midplane of the galaxy every 30 million years. Each crossing subtly increases the gravitational disturbances we experience. Some scientists quietly wondered, did these crossings influence mass extinctions? Did motion through the galaxy shape life itself? NASA does not confirm, but it does not deny. As Earth moves through different regions of the galaxy, the radiation environment changes. Cosmic rays increase, then fade. Interstellar dust thickens, then thins. The galaxy is not empty, it is textured, and Earth is brushing through it. Now pause. Consider this. You are not simply on a planet. You are on a vehicle with no brakes, no steering wheel, no windows, only instruments, and trust. NASA watches. but it cannot stop. Earth's journey is guided by gravity. Gravity is not a force that pulls. It is a curve in space. Time. Mass tells space how to bend. Space tells mass how to move. NASA's equations show Earth following the curvature carved by the Sun. The Sun follows the curvature carved by the galaxy. The galaxy follows curvature shaped by even larger structures. Motion nested inside motion. Direction. Here is where the suspense deepens, because Earth's motion is not perfectly predictable forever. Tiny variations exist. Minute shifts, gravitational nudges from Jupiter, tugs from passing stars, waves from galactic tides over millions of years. Small changes accumulate. Chaos does not announce itself, it whispers. NASA has run simulations projecting Earth's orbit millions of years into the future. Most outcomes are stable, but some diverge. Not catastrophic, not dramatically, just enough to remind us stability is not permanence. And yet, despite all of this movement, feels calm. Solid. Reliable. That calm is not an accident. It is the result of balance. Earth's rotation stabilizes climate. Its orbit stabilizes seasons. Its moon stabilizes axial tilt. Remove any one of these, and the planet becomes hostile. NASA calls this the dance. A dance with steps, so precise that one misstep could erase life as we know it. But dances have tempo, they have rhythm, they have direction, and this is where the question sharpens. If Earth is moving around the Sun and the Sun is moving through the galaxy and the galaxy is moving toward something larger than Earth's path is not random, it is being guided. Not consciously, not intentionally, but inevitably. You are not drifting aimlessly through space. You are being carried along a corridor shaped by gravity, time, and mass. A corridor that began long before Earth formed. A corridor that leads somewhere. NASA does not yet tell us where that somewhere is, only that Earth is already on the way. Every sunrise, a little farther, every night, deeper into motion. So here is the question that should stay with you as Earth continues its silent journey. If our planet has a path through space, and that path leads beyond our control, what lies ahead waiting for us along the way? The Sun is moving, not gently, not symbolically, not as a background detail. The Sun is racing through space, carrying every planet, every moon, every asteroid, and every fragile world in its grip, including us. NASA didn't reveal this to make us feel small. It revealed it because the solar system is not what it appears to be. It is not a calm, balanced clockwork, quietly spinning in place. It is a traveler, and once you understand the Sun's journey, you realize something unsettling. Earth is not orbiting a stationary star. Earth is orbiting a moving engine, pulling us through a galaxy that never stops shifting. From our perspective, the Sun feels permanent. It rises, it sets, it returns, day after day, year after year. But this repetition is deceptive, because while the Sun appears to trace the same path across our sky, it is never in the same place twice. Not in space, not ever. NASA tracks the Sun's motion using reference points far beyond our solar system. Distant stars, quasars, radio, beacons, billions of light years away. Against these fixed cosmic markers, the Sun drifts, not slowly, not subtly, but at an extraordinary speed. the sun moves around the center of the Milky Way at approximately 828,000 kilometers per hour. That number is not abstract. It means that in the time it takes you to fall asleep tonight, the sun will have carried Earth hundreds of thousands of kilometers through space, and you will feel nothing. Imagine standing on the deck of a ship so large, so smooth, and so constant in its motion that the ocean appears frozen, the wind silent, the horizon unmoving. You would believe you were still until you looked at the stars. NASA's instruments look at the stars, and they reveal that our solar system is cutting through the galaxy like a vessel through deep water ahead of us. Stars slowly approach. Behind us, stars fall away. This is called solar apex motion, the direction the sun is heading, and it has a name. The sun is moving toward a point near the star Vega, in the constellation Lyra, not toward Vega itself, but toward that region of space, a cosmic heading, a direction of travel, a destination without arrival. Let that settle. Our entire solar system has a heading, a forward direction, a galactic north that is not marked on any human map. NASA doesn't describe this motion emotionally, but emotionally it matters, because it means we are not drifting aimlessly. We are going somewhere as the sun moves. It drags a gravitational domain with it. This domain is called the heliosphere, a vast bubble of solar, wind, and magnetic fields extending billions of kilometers outward. Inside this bubble, the sun dominates. Outside it, the galaxy begins to interfere. NASA's Voyager probes crossed the boundary of this heliosphere, and when they did, they entered interstellar space. Not empty space, but a different environment, a different pressure, a different flow. The heliosphere acts like a shield. It deflects high energy, cosmic radiation. It protects Earth from the raw violence of the galaxy. And as the sun moves, this shield collides with the interstellar medium, compressing in front, stretching behind, like a cosmic wake, which raises a quiet question. If the sun's shield changes shape as it moves, what happens when it moves into denser regions of the galaxy? NASA has evidence that it already has. The solar system has not always traveled through the same galactic neighborhood over millions of years. It passes through thin clouds of gas-dense molecular regions, magnetic turbulence, cosmic ray, hotspots. Each region subtly alters the radiation reaching Earth. Each region whispers into climate, into mutation, into evolution. The sun's motion is not smooth. It oscillates like a pendulum, up and down through the Milky Way's disk, top crossing regions thick with stars, then drifting into quieter voids. This vertical motion takes tens of millions of years. Slow enough to feel eternal, fast enough to matter. Some scientists quietly suspect that Earth's biological rhythms may be tied to these crossings, not proven, not confirmed, but considered, because motion leaves fingerprints, even when it moves too slowly to see. Now, let me tell you something NASA simulations show but rarely emphasize. The solar system does not move alone. It travels as part of a stellar stream, a loose association of stars born in similar regions, moving in similar directions, like a forgotten family drifting apart over billions of years. The sun has siblings. Most are lost, some still nearby, all moving. This means the sun's path is influenced by nearby stars. Passing stars tug gently. Their gravity distorts the outer solar system. the Oort cloud, a vast shell of icy objects surrounding us. When a star passes close enough, sends ripples through this cloud, comets fall inward, some toward the sun, some toward Earth. Mass extinctions may begin this way, not with explosions, but with motion. NASA studies these stellar encounters carefully because the solar system's journey is not empty. It is crowded, dynamic, unforgiving. Even now, the sun is approaching different gravitational influences than it experienced millions of years ago. Nothing dramatic, nothing immediate, but direction matters. Given enough time, even gentle curves lead far from the starting point. And then there is this. The Milky Way itself is not static. Its spiral arms rotate. Density waves move through them. Stars drift in and out. The sun is not locked inside one arm. It passes through. Like a traveler crossing a city at night. Each spiral arm crossing exposes Earth to higher supernova risk, more massive stars, more explosions, more radiation. NASA tracks remnants of ancient supernova near our past trajectory. Evidence of close calls, near misses, moments when Earth survived quietly. So pause here. The sun is moving, the galaxy is active, the environment changes, and Earth is inside it all, unaware, unprotected, except by timing. Here is where the illusion of stability fully collapses. Because when you imagine the solar system, you imagine order, balance, predictability, but NASA's data shows something else. It shows controlled chaos. Motion stabilized by motion, danger canceled by distance, survival negotiated moment by moment. The sun's gravity binds us, but it also limits us. We cannot stop, we cannot turn, we cannot slow down. The solar system has momentum older than humanity itself, and yet despite this relentless movement, life persists, sleep continues. Dreams unfold as the universe carries us forward without asking. So let me leave you with the question that grows heavier the longer you sit with it. If the sun is moving and the solar system has a heading and we are being carried deeper into the galaxy, what exactly are we moving toward? The Milky Way is moving, not rotating, not expanding internally, moving as a whole. Every star, every planet, every cloud of gas and dust, all drifting together through a universe far larger than the galaxy itself. NASA did not always know this. For a long time, the Milky Way was treated as a reference frame, a background against which everything else moved. But the background turned out to be moving to dot, and once NASA measured that motion, the universe became far more unsettling, because a galaxy does not drift unless something pulls it from inside the Milky Way. Motion is almost impossible to feel. Stars appear fixed. Constellations barely change across generations. The night sky feels eternal, but NASA doesn't rely on feeling. It relies on comparison. By measuring the motion of distant galaxies far beyond our own, NASA discovered something strange. The Milky Way is not sitting quietly in space. It is part of a larger flow, a coordinated movement involving thousands of nearby galaxies. A slow, silent migration. This flow has a direction, not symbolic, not philosophical. A measurable heading across the cosmic map. And once that heading was identified, astronomers gave it a name, the local group motion. Our galaxy belongs to a small family called the local group. It includes Andromeda, the Triangulum Galaxy, and dozens of smaller galaxies. Together, they are bound by gravity. Together, they move. NASA measurements show that the entire local group is traveling at roughly 600 kilometers per second. That is more than 2 million kilometers per hour, a speed so vast it erases intuition. Yet still, nothing feels different. This motion was detected by studying the cosmic microwave background, the faint afterglow of the Big Bang. This radiation fills all of space. It should look the same in every direction, but it doesn't. In one direction, the radiation appears slightly warmer. In the opposite direction, slightly cooler. This temperature difference is tiny, but precise. And it tells a story. It tells us that we are moving, not just Earth, not just the Sun, not just the Milky Way, but everything we belong to. NASA calls this pattern a dipole anisotropy, a technical phrase, but emotionally it means this: there is a front, and there is a back, a cosmic wind, and we are traveling through it. The direction of this motion points toward a region of space dense with galaxies and mass, a place where gravity accumulates, a place that bends space-time strongly enough to pull entire galaxy clusters. This region lies in the direction of the Centaurus and Norma clusters, hidden behind the thick dust of the Milky Way itself, invisible to ordinary telescopes, but undeniable in its influence. The Milky Way is not drifting freely. It is being drawn, like iron filings responding to a magnet they cannot see. NASA refers to this large-scale motion as part of a bulk flow. Galaxies moving together over hundreds of millions of light-years, not randomly, not chaotically, but coherently. This should not happen easily. On these scales, the universe should be smooth, balanced, uniform, but it isn't. Single quotes. There are imbalances, overdensities, regions, where mass has quietly accumulated over billions of years. These regions bend the paths of galaxies. Imagine a valley forming in space, time, not steep, not dramatic, just deep enough, everything nearby begins to lean toward it. NASA's maps reveal this leaning. Galaxy after galaxy, cluster after cluster, all subtly angled in the same direction, and the Milky Way is one of them. This motion is not temporary. It has been happening for hundreds of millions of years, and it will continue for hundreds of millions more, because gravity does not rush, it waits. Even more unsettling than Milky Way is not moving alone. It is part of a supercluster, a vast network of galaxy groups. These superclusters themselves are arranged along enormous filaments, like threads in a cosmic web. Between these filaments are vast voids, regions almost empty of matter. Gravity pulls galaxies away from emptiness toward density. So the Milky Way is not just being pulled toward something, it is also being pushed away from nothing. This dual motion, attraction and evacuation, defines the universe's large-scale flow. NASA's simulations show galaxies sliding along invisible highways carved by gravity. Highways millions of light-years long. And here is where the idea of a destination becomes unavoidable. Because highways lead somewhere, even if no one knows exactly where. Astronomers identified one particularly dominant influence in our region of space, a gravitational anomaly. So massive, so influential, that it reshapes the motion of tens of thousands of galaxies. They gave it a name that feels more like a warning than a label: the Great ATTRACTOR. NASA did not choose this name lightly, because whatever it is attracting us. The Great Attractor lies approximately 150 to 250 million light-years away in a region obscured by our own galaxy's dust. Hidden, difficult to observe, but impossible to ignore, the Milky Way is moving toward it, and so is Andromeda, and so are countless other galaxies, all converging. But here is the detail that keeps scientists awake. The Great Attractor is not a single object. It is not one galaxy, not one cluster. It is a region, a concentration of mass so large that its gravity dominates the local universe. NASA's observations suggest it includes massive galaxy clusters, dark matter concentrations, possibly structures we do not fully understand yet even. This may not be the final pull, because beyond the Great Attractor, there appears to be something even larger, an even deeper gravitational well. Some call it the Shapley supercluster, a structure so massive it challenges our understanding of cosmic balance. It may be influencing the Great Attractor itself, pulling the puller, guiding the guide. If that is true, then the Milky Way's destination is not local, not temporary, but part of a much larger cosmic convergence. And this is where the sense of inevitability settles in, because gravity does not negotiate, it does not reconsider, it does not forget. The Milky Way is moving because it must, because the universe's mass distribution demands it, because space-time curves where mass accumulates. You are not drifting through an indifferent cosmos. You are embedded in a structured one with flows, directions, trends. And yet, despite all this motion, the night sky remains calm. Stars still twinkle. The illusion holds, but now you know the Milky Way has a destination, not a final stop, not an arrival point, but a direction of deeper motion. So here is the question that should quietly echo as you drift toward sleep. If our entire galaxy is being drawn toward something we cannot fully see, and that pull has shaped our past for hundreds of millions of years, what happens when we finally get closer? The pull is already acting on us. Not suddenly, not violently, not in a way your body can feel, but patiently, silently, relentlessly. NASA did not invent the Great Attractor. They stumbled upon it by noticing something that should not have been happening. Galaxies were moving, but not away from each other the way cosmic expansion predicts. They were drifting toward something, and that something was hidden. At first, the motion looked like noise, random velocities, measurement errors, unexplained anomalies. But as NASA refined its instruments and expanded its maps, a pattern emerged. Galaxies were leaning, clusters were sliding, entire regions of space were flowing in the same direction, not toward us, past us, through us. Like a slow cosmic current, we happen to be inside the Great Attractor. Sits behind the densest region of our own galaxy, a zone astronomers call the zone of avoidance. Here, dust clouds and stars block our view. Visible light cannot penetrate it. For decades, whatever lay beyond remained hidden. But gravity does not care about dust, and gravity was speaking loudly. NASA began to see it indirectly, through the motion of galaxies, through distortions in background, radiation, through subtle warps in space-time. The Great Attractor revealed itself not by light but by influence. Imagine standing in a dark room. You cannot see what is there, but you feel the air moving, toward a single point. You feel objects sliding across the floor. You feel yourself leaning. You do not know what causes it, only that it exists. That is what the great attractor feels like to the universe. NASA estimates its mass to be equivalent to tens of thousands of Milky Ways, possibly more. A concentration of matter so immense it dominates the local gravitational landscape. But here is the detail that deepens the mystery. Even with that much mass, the observed pull is stronger than expected, as if something else is helping, as if visible matter alone is not enough. Dark matter enters the story here, not as a theory, as a necessity. Galaxies rotate too fast. Clusters hold together too tightly. Large-scale flows behave too coherently. Without dark matter, the equations fail. With it, the great attractor becomes plausible. NASA believes the great attractor is saturated with dark matter, an invisible scaffold amplifying gravity, guiding motion, shaping destiny. But dark matter does not emit light. It does not reflect. It does not interact with us except through gravity, which means we are being pulled by something we cannot see. And the great attractor is not alone. It is part of something larger, a structure within a structure. Beyond it lies the Shapley supercluster, one of the most massive formations in the observable universe. A gathering of galaxy clusters so vast it bends cosmic expansion locally. Some data suggests that what we call the great attractor may simply be the nearest slope of a deeper gravitational valley. Not the destination, just the incline. If that is true, then the Milky Way is not heading toward one structure. It is descending into a region of increasing mass, a convergence zone, a basin. NASA's simulations show galaxies accelerating subtly as they approach these regions, not speeding dramatically, just enough to confirm attraction, enough to prove inevitability. But attraction is not collision, not immediately on these scales. Gravity works over hundreds of millions of years. Galaxies do not crash like cars. They merge like fog, slowly, quietly, and yet there is something deeply unsettling about knowing that your entire galaxy is drifting toward an unseen mass, a pull older than humanity, stronger than imagination, patient enough to wait for stars to die. Here is what NASA does not say loudly. The great attractor may never be fully observable. By the time light from its deepest regions reaches us, the universe will have expanded further. Distances will stretch. Signals will fade. We may be forever chasing its shadow, feeling its pull, never seeing its source. Even now, the Milky Way is falling toward it at hundreds of kilometers per second, not dramatically, not noticeably, but constantly. This motion affects everything: galaxy shapes, star formation rates, the trajectories of clusters. Even the future collision between the Milky Way and Andromeda is influenced by these larger flows. Nothing is isolated, not even galaxies. And this is where the thought becomes heavier, because the great attractor is not a conscious entity. It is not aiming, it is not choosing. It is simply obeying the geometry of mass and space-time, which means the universe has direction without intention, motion without meaning, or perhaps meaning is something that only emerges inside the flow. NASA does not assign purpose to the great attractor, but its presence reshapes our cosmic map. It tells us that the universe is not evenly balanced. It has gradients, slopes, directions, And wherever there is a slope, everything rolls. So here we are, on a planet, around a star, inside a galaxy, inside a group, inside ASUPERCLUSTER, all leaning, all drifting, all descending. The great attractor does not pull violently, it pulls patiently. It gives the universe time to forget it is moving. And yet even patience has an end point. Which brings us to the quiet question that cannot be answered yet. If the great attractor is only part of something larger, and everything we know is already falling toward it, what lies at the bottom of the universe's deepest gravitational well? The universe is moving in a way that does not feel like movement at all. There is no direction you can point to, no wind you can measure, no center you can travel toward, and yet everything is separating, quietly, relentlessly. NASA did not discover this by watching galaxies fly apart. They discovered it by noticing something far more unsettling. Space itself is changing. When Edwin Hubble first observed distant galaxies, he noticed a pattern. The farther away a galaxy was, the faster it appeared to be moving away. At first, this seemed like ordinary motion, but it wasn't, because galaxies were not simply traveling through space. They were being carried apart by space itself. NASA later confirmed this with precision instruments, satellites, and decades of observation. The universe is expanding, not from a center, not into emptiness, but everywhere, all at once. Let me say that slowly. The universe is not expanding in space. Space is expanding within the universe. That difference matters. Imagine dots drawn on the surface of a balloon. As the balloon inflates, the dots move away from each other. No dot is the center. Every dot sees the others receding, and none of the dots are actually moving on the surface. The surface is stretching. That is what the universe is doing. Galaxies are not fleeing. They are being separated, carried apart by the quiet growth of space itself. NASA measures this expansion using a value called the Hubble constant. It tells us how fast the universe is expanding at different distances. And here is where the unease deepens. The expansion is not slowing down, it is accelerating. Something is pushing, not pulling, not attracting, but driving space to expand faster and faster over time. NASA calls it dark energy. Dark energy does not behave like matter. It does not clump, it does not gather, it does not form structures. It stretches space everywhere, even inside the vast voids between galaxy clusters, and it is winning on small scales. Gravity dominates. Stars hold together, galaxies remain bound, clusters persist. But on the largest scales, expansion overwhelms gravity. Filaments stretch, distances grow, connections weaken, which means this: the great attractor pulls galaxies together locally, but dark energy pulls the universe apart globally. Two opposing tendencies, two cosmic influences, one gathering, one dispersing. NASA's maps show this tension clearly. Matter tries to clump, space tries to stretch, and the universe becomes a battlefield between attraction and expansion. This changes how we think about direction, because in an expanding universe, there is no universal toward, only relative separation. The Milky Way is moving toward the great attractor, but the space between superclusters is expanding, which means some destinations recede faster than we can ever reach them. There are galaxies so distant that even if we traveled at the speed of light, we would never arrive, because the space between us and them grows faster than light can cross it. NASA calls this the cosmic event horizon. Beyond it, the universe becomes unreachable forever. Those galaxies still exist, they still shine, but their light will never reach us, not now, not ever again, which means the observable universe is shrinking, not physically, but causally over time. More galaxies will cross the horizon. They will fade, stretch, disappear in the far future. The Milky Way may appear alone, surrounded by darkness, not because the universe is empty, but because expansion has isolated us. This is motion on a scale the mind resists, not travel, not drift, but detachment. NASA's data suggests dark energy makes up nearly 70% of the universe. Matter, everything we can see, is a minority. The universe is not dominated by stars. It is dominated by something we do not understand. And dark energy does not care about direction. It does not point. It does not aim. It simply expands, which creates a strange paradox. The universe has flows, like the great ATTRACTOR, but the universe as a whole has no preferred direction. Locally, everything moves toward something. Globally, everything moves away from everything else. Both are true at the same time. NASA simulations show that over billions of years, clusters will become islands, each one isolated in its own expanding bubble of space. Communication impossible, travel meaningless, and yet within each island gravity still works. Stars still form, planets still orbit, life could still exist. Motion becomes layered, nested, contradictory. You are moving toward the great attractor, while the universe expands away from itself, while space stretches beneath your feet, which raises a deeply unsettling thought. If expansion continues forever, then motion eventually loses context. No landmarks, no destinations, no shared reference, just isolated regions drifting into silence. NASA does not yet know what dark energy is. It could be a property of space itself, a new field, a breakdown of our understanding of gravity, something even stranger. But whatever it is, it determines the universe's ultimate fate. If dark energy remains constant, expansion continues forever. If it grows stronger, the universe tears itself apart. If it weakens, gravity may regain control. The ending is not written yet, but the motion is already underway, and this is where Chapter 6 must not end, because expansion does not explain direction, it complicates it. If everything is moving apart, why do large flows still exist? Why does the great attractor still pull? Why does structure still form? The answer lies deeper, beyond expansion, beyond gravity. NASA's newest observations suggest the universe has structure on the largest imaginable scales, patterns, alignments, unexpected coherence, which leads to a dangerous question scientists rarely say out loud. What if the universe has a preferred direction after all? Not a center, not a destination, but an orientation. Some data hints at asymmetries, ANISOTROPIES, subtle alignments across billions of light-years, nothing confirmed, nothing certain, but enough to make researchers uncomfortable. Because if the universe itself is not perfectly uniformed, then motion may not be random, and expansion may not be the final story. So, as space continues to stretches, galaxies drift beyond reach as dark energy dominates, another question quietly forms. Beneath all of this motion, if the universe is expanding and still showing hidden structure and still guiding matter into flows, what deeper pattern is shaping everything we see? The question does not begin loudly. It does not announce itself. It emerges slowly after everything else has been stripped away. If planets rotate, if stars rotate, if galaxies rotate, then what about the universe itself? NASA never assumed the universe was rotating for decades. The safest assumption was symmetry, uniformity, no preferred direction, no cosmic spin, because rotation implies something uncomfortable, a beginning, a torque. Yet, when astronomers began looking closely enough, not at stars, not at galaxies, but at the largest possible patterns, something subtle appeared. Not motion, not speed, but alignment. The universe, it seemed, might not be as indifferent as we thought. Let me slow this down. Rotation is easy to recognize when something spins. Quickly, planet, a star, a galaxy, dot. But on the scale of the universe, rotation would be unimaginably slow. So slow that one full turn could take longer than the age of time itself. NASA cannot watch the universe spin, but it can look for fingerprints. Those fingerprints appear in the cosmic microwave background, the faint afterglow of the Big Bang. This radiation fills all of space. It should be random, uniform, directionless, but it isn't perfectly so. When NASA's satellites mapped this radiation in exquisite detail, they found something disturbing: large-scale patterns, temperature variations aligned across vast distances, structures too big to be coincidence. At first, scientists dismissed it. Instrument error, foreground, contamination, statistical flukes. But the patterns persisted. Different satellites, different methods, same alignments. Some of these features appeared to line up along a single cosmic axis, an axis with no obvious reason to exist. Astronomers gave it an uneasy name, the axis of evil, not because it is sinister, but because it breaks assumptions. The axis of evil suggests that the universe might have a preferred orientation, not a center, not a destination, but a directional bias. If true, this changes everything, because a rotating universe would not be perfectly isotort. It would carry memory, momentum, history. NASA does not claim the universe is rotating, but it does admit the data is strange, uncomfortably strange, some theoretical. Models allow for slow cosmic rotation, so slow that it would not tear galaxies apart, so subtle that it would only appear in the deepest background radiation. In these models, the universe expands, but it also twists, barely, almost imperceptibly. Imagine dough rising, expanding outward, but with a gentle rotation applied. Not enough to notice at first, only enough to leave patterns. If the universe rotates even slightly, then every structure inside it inherits that motion. Galaxies, clusters, flows, rotation would explain certain alignments, preferred axes, large scale, coherence. But rotation demands an origin, something that started the spin, something that broke perfect symmetry. And this is where discomfort deepens, because the Big Bang was supposed to be symmetric, no direction, no bias, just expansion. Rotation suggests asymmetry from the very beginning. A universe born, not perfectly balanced, but tilted. NASA approaches this idea cautiously, because once symmetry breaks, so do many comforting assumptions. A rotating universe could mean the laws of physics, very subtly, with direction, time itself, may have a global orientation. The universe carries angular momentum from birth. None of this is proven, but none of it has been ruled out. Some researchers examine galaxy rotation, directions, clockwise, counterclockwise, across different regions of the sky. If orientations were random, they should average out, but some studies suggest a slight imbalance, not overwhelming, not decisive, just enough to whisper, what if the universe remembers which way it turned first? Even more unsettling, if the universe rotates, there may be a cosmic frame of rest, after all, a background orientation hidden beneath expansion. That would mean motion is not entirely relative, that there exists a deeper reference. NASA remains cautious, extraordinarily cautious, because extraordinary claims reshape cosmology. Still, the patterns remain, the alignments persist, the questions do not go away, and rotation would also interact with expansion, twist it, shear it, distort large-scale flows. The great ATTRACTOR bulk motions, filaments, voids, they might not be random outcomes of gravity alone. They might be shaped by a subtle cosmic spin, not fast, not dramatic, but patient, ancient. If truth, then direction is not just local, it is inherited. Which brings us back to you. You are moving because Earth rotates, because the sun travels, because the Milky Way flows, because superclusters drift. But what if all of that motion sits inside something larger, something rotating so slowly that its influence only appears across billions of light years? NASA cannot yet answer this, but it cannot ignore it either. And here is the most unsettling part. If the universe rotates, then time itself may not be symmetric. There may be a preferred temporal direction, not just entropy, but orientation. Time might not only flow forward, it might spiral. This is not science fiction, it is mathematics, quietly waiting for confirmation. The universe would not simply expand and cool, it would twist as it goes, leaving fingerprints in radiation, alignments in structure, biases in motion, and perhaps a reason why the universe looks the way it does. NASA continues to observe, to refine, to hesitate, because some discoveries cannot be undone once accepted. If the universe rotates, then stillness never existed. Even at the beginning, motion would be fundamental, not emergent. And the question shifts no longer, where are we going, but something far stranger. If the universe itself is slowly turning, if everything we see is carried inside that rotation, if direction exists on the largest scale of all, then what happens when that motion intersects with time itself? The name was never meant to sound dramatic. It was never meant for documentaries, headlines, or late-night thoughts. It began as a joke, a quiet one, among scientists who noticed something that should not exist, and yet once seen, it could not be unseen. The axis of evil is not a structure. It is not an object. It is not a force you can point to in space. It is a pattern, a directional alignment hidden in the oldest light in the universe. NASA did not go looking for it. They found it by accident. When the cosmic microwave background was mapped in detail, scientists expected randomness, tiny temperature fluctuations, statistical noise, no large-scale order. Instead, they found alignment. Large regions of slightly warmer and cooler radiation appeared to line up along a single axis across the entire sky. This axis had no physical reason to exist, no theoretical requirement, no prior prediction, and yet there it was. The universe, it seemed, had a preferred orientation. At first, the reaction was denial, foreground interference, instrument bias, data processing artifacts, but each new satellite confirmed it. Different instruments, different methods, same alignment. NASA refined the data, filtered out noise, removed known contaminants. The axis remained. This was unsettling for a simple reason. Cosmology is built on a principle called cosmic isotropy. The idea that the universe looks the same in every direction. The axis of evil violates that idea. If the universe has a preferred axis, then it is not perfectly uniform, not perfectly symmetric, not perfectly indifferent. The axis appears to align with the plane of our solar system. That detail alone raised alarm, because coincidence on this scale is unlikely. Some dismissed it as observer bias, our position, our motion, our instruments. But even after accounting for these, the alignment persisted. The universe was whispering something uncomfortable. The axis of evil does not rotate like a wheel. It does not spin visibly. It is not motion in the traditional sense. It is orientation, like the grain in wood, like a subtle tilt in fabric, something that tells you which way is with the universe and which way is against it. NASA does not claim the axis of evil proves the universe is rotating, but it suggests something deeper, that the universe may have memory of initial conditions, memory of imbalance, memory of a direction chosen at birth. If the Big Bang were perfectly symmetric, no axis should exist. But symmetry is fragile. Even tiny fluctuations in the earliest moments could imprint direction forever. And once imprinted, everything that follows inherits it. Galaxies form, clusters align, flows emerge. The great attractor, bulk motion, filaments, all could be downstream effects. This reframes everything. We are not just moving through space, we are moving within a structured orientation, which raises an unsettling thought. What if the direction everything is moving is not accidental, but inherited from the very beginning? The axis of evil is faint, subtle, but it spans the entire observable universe. It does not care about distance. It does not weaken with scale. It suggests that the universe, at its largest, is not neutral. NASA remains cautious because accepting this would mean rewriting foundational assumptions. A universe with a preferred axis could mean slight variations in physical laws, bidirection, asymmetries, in time's behavior, hidden global motion. None of this is confirmed, but none of it has been disproven. And here is where the discomfort deepens. The axis appears aligned with our motion through the universe, our velocity relative to the cosmic background, as if we are not just moving through the universe, but with its grain, like swimming downstream instead of against the current dot, which raises a quiet question. Are we observing the universe, or is the universe observing us move through it? NASA has no answer, only more data. Some models suggest the axis could emerge from quantum fluctuations stretched by inflation. Others suggest new physics. Others suggest the universe is larger and stranger than the observable part. And then there are ideas rarely spoken aloud. What if our observable universe is just a region inside something larger? A bubble, a domain with its own orientation. The axis could be a boundary effect, a hint of structure beyond what we can see. If so, then direction does not end at the edge of observation. It continues. And now, consider this. The axis of evil aligns with temperature patterns. Temperature reflects energy. Energy reflects time. What if the axis is not just spatial, but temporal? What if time itself prefers a direction, not just forward, but oriented? NASA does not claim this, but physics allows the possibility. Entropy gives time an arrow, but entropy does not explain alignment. If time has orientation and motion through time is not neutral, then history itself leans. Then the universe is not just expanding and evolving, it is unfolding along a bias. This bias could shape everything. Why structures form where they do, why flows align, why we exist where we do. And this brings us to a deeply personal realization. You are not just moving through space, you are moving along a cosmic orientation, older than stars, the Earth, the Sun, the galaxy, the CAS, the ESUPERCLUSTER, all embedded, and you feel none of it, because awareness evolved to survive locally, not cosmically. NASA continues to watch, to measure, to hesitate, because the axis of evil does not shout, it whispers, and whispers are harder to ignore than noise. So as the universe expands, as galaxies drift beyond reach, as dark energy stretches space, another layer of motion reveals itself. Not movement through distance, not drift through time, but orientation through existence, which leads to the question that cannot yet be answered. If the universe has an axis, if everything we see is aligned along it, if motion, time, and structure follow its orientation, then is the universe simply expanding, or is it slowly turning toward something we have not yet named? Time is moving. You feel it constantly, but you never feel its direction. You only notice its passing after it has already gone. NASA does not treat time as a feeling. It treats time as a dimension. And when time is studied the way space is studied, something unsettling appears. Time does not behave symmetrically. It flows, and it flows in one direction only. You can walk north or south. You can move left or right. You can return to a place you once left, but you cannot return to a moment that has passed, not even slightly. This is not a limitation of technology. It is a property of the universe. NASA asks a quiet question behind every equation. Why does time have an arrow? The laws of physics mostly do not care which way time flows. Atoms behave the same forward or backward. Equations work in either direction. Yet, reality does not. A glass shatters. It never unshatters. Stars burn fuel. They never unburn it. Memories form. They never form in reverse. This asymmetry is everywhere, and it is tied to motion. Time's direction is linked to entropy, the measure of disorder. Entropy increases, always. NASA describes entropy as the reason why the universe remembers the past, but forgets the future. Low entropy states are rare. High entropy states are common. The universe began in an incredibly low entropy condition, smooth, ordered, improbable. From that moment onward, entropy increased, structure formed, stars ignited, galaxies assembled, life emerged. All because time moved forward. But here is the discomforting part. The equations do not demand that entropy increase. They allow it, but they do not force it. So why did the universe begin in such an ordered state? Why did time start with a direction already chosen? NASA does not yet know, but the answer may be tied to motion on the largest scale. If the universe has orientation, if it has an axis, if it rotates or carries memory, then time's arrow may not be accidental. Time may be aligned. Some physicists suspect that time's direction is inherited from the universe's initial conditions, not imposed later, not emergent, but built in, which means time is not just flowing, it is pointing. This aligns disturbingly well with everything else. Galactic flows, bulk motion. Cosmic expansion, preferred orientations. What if time flows with the universe's motion? NASA observes that clocks behave differently depending on motion. Time slows near massive objects. Time slows at high speeds. Motion distorts time. This is not philosophy. It is measurement. Satellites must correct for time. Dilation GPS would fail without it. Time is not universal. It is local, which raises a question that feels uncomfortable the longer you sit with it. If time flows differently, depending on motion and everything in the universe is moving, then no two regions experience time the same way. The universe does not share a single now. There is no cosmic present, only overlapping timelines sliding past one another. NASA's observations suggest that as the universe expands, time stretches with it. The early universe experienced time differently than we do. Faster, hotter, denser. As space expands, processes slow. Stars live longer. Reactions cool. Time itself seems to relax, which hints at something deeper. Time may be tied to expansion. As space grows, time flows. As expansion accelerates, the future lengthens. Dark energy does not just stretch space, it stretches time's horizon. The farther the universe expands, the more isolated each region becomes. Causality weakens, information exchange fades. In the far future, time may still flow, but with nothing left to change. And this is where the idea of direction becomes haunting. Time flows because things change. But what happens when change becomes impossible? NASA studies the possible futures of the universe. None are gentle. Heat death, big rip, big freeze. In every scenario, motion slows, structures decay, differences fade, entropy wins. And yet, the arrow of time continues, which leads to a quiet paradox. If the universe ends in equilibrium, why does time keep moving toward it? Why not stop? Some physicists suggest that time does not exist fundamentally, that it emerges from change, that when nothing changes, time dissolves. But NASA continues to measure time even where nothing appears to happen. Atomic clocks tick, particles decay, space vibrates, time persists, which suggests time is not merely a consequence. It may be a driver. Now let this thought settle. If time has direction, then the universe has orientation. Then the flow of time may not be random. It may be aligned with the same cosmic direction that guides galaxies. The great attractor pulls matter. Dark energy stretches space. The axis aligns. Structure. Time flows. These may not be separate phenomena. They may be different expressions of the same underlying geometry. NASA does not say this openly. but modern physics allows it. Time could be another dimension shaped by mass and expansion, not independent, not absolute, which means the future is not simply ahead. It may be downstream, downstream of cosmic motion, downstream of expansion, downstream of entropy, and you are moving with it every second, without resistance, without pause. You cannot turn around, you cannot stop, you cannot step aside. Time carries you the way space carries galaxies. And here is where the unease becomes personal. If time has direction, then so does history. Some futures are reachable, others are not. The universe may be guiding outcomes without intention, not deciding, but constraining. NASA calls this the cosmic boundary of possibility. What can happen, what cannot, as entropy rises. Options collapse, choices narrow, paths close. The early universe was full of possibility. The future is narrower. Time does not just pass. It filters, which raises a final question for this chapter, one that does not answer itself. If time flows in a direction shaped by the universe's motion, if the future is downstream of cosmic structure, if entropy, expansion, and orientation are connected, then are we moving freely through time, or are we being carried toward something inevitable? Everything is still moving. Even now, even at the end of the story, NASA never says the universe is slowing down. They say it is accelerating, and acceleration always points somewhere. The question is no longer whether the universe is moving in a direction. That much is unavoidable. The question is whether that direction leads to an ending or something that looks disturbingly like a beginning. For most of human history, endings were imagined as collapses, the sky falling, the stars going dark, everything folding back into itself. But NASA's data tells a quieter, colder story. The universe is not collapsing, it is stretching, not rushing, not tearing violently, just pulling itself apart. Dark energy dominates the cosmos. It does not slow, it does not weaken, it does not dilute. As space expands, dark energy becomes more influential, which means the future is not dense, it is empty. Galaxies drift farther apart, clusters lose contact, light from distant regions will never reach us again. The observable universe shrinks, not physically, but causally. Eventually, even nearby galaxies disappear beyond the cosmic horizon, not destroyed, just unreachable. NASA calls this cosmic isolation, a future where every galaxy exists alone. Stars will still burn for a time, then star formation will stop, gas will thin, energy will disperse. Black holes will dominate the mass budget of the universe. Silent, patient, even. They will not last forever. Over unimaginable spans of time, black holes evaporate, particle by particle, hawking radiation. The universe becomes colder, darker, flatter. This scenario is known as heat death, not an explosion, not a collapse, just an exhaustion. And yet something about this ending feels incomplete, because motion does not stop, expansion continues, time continues, entropy continues, which leads to a troubling thought. If the universe never stops expanding, then time never stops flowing. But what does time mean when nothing changes? NASA cannot answer that, but physics allows something stranger. Some theories suggest the universe may not end. It may recycle, not by collapsing, but by transitioning. One possibility is that dark energy is not constant, that it may change, decay, flip, sign. If that happens, expansion could reverse, slowly, quietly. The universe could begin to contract. Another possibility is more unsettling. The universe may undergo eternal inflation, constant creation of new regions, new universes budding off endlessly. In this view, our universe is not the whole, it is a bubble, a region, a phase. If so, then endings are local, not universal. Even heat death may be temporary. Some physicists explore the idea of cosmic bounce, a universe that expands, then resets, then expands again, not repeating exactly, but echoing. And here is where direction becomes unsettling again. If the universe cycles, then motion never truly ends. It loops. Time may still flow forward locally, but globally, patterns return. NASA does not claim this, but their observations do not forbid it. The cosmic microwave background hints at anomalies, unexplained alignments, memory-like structures, as if the universe remembers something. If the universe remembers, then it has a past beyond the Big Bang, which would mean the beginning was not the beginning, and the direction we are moving in may not be away from something. It may be toward a familiar state. Now let the scale shrink. Our galaxy will collide with Andromeda in about 4 billion years. Not a crash, a merger. Stars will mostly pass by one another. Orbits will reshape. A new galaxy will form, even locally. Endings become beginnings. Stars die. Their remnants seed new stars. Supernova destroy, create. Black holes consume and radiate. Nothing truly stops, which leads to the most uncomfortable possibility of all. The universe may not be moving toward an end, it may be moving toward maximum balance, a state where nothing changes, because everything is already everywhere it can be. And if that state is stable, then time may lose meaning. But if it is unstable, then something must disturb it. A fluctuation, a quantum tremor, a new expansion, a new universe. Which raises a final thought that NASA never states directly, but never dismisses either. The universe may be moving through phases, not toward conclusions, and we are simply inside one of them. So when we ask, where is everything going? The most honest answer may be, everywhere it has already been, just not yet. Because motion is not about destination, it is about continuity. And the universe does not appear to know how to stop, even now as you listen as your thoughts, slow as your awareness, drifts. You are still moving around Earth, around the sun, through the galaxy, toward unseen structures, along the arrow of time, with the expansion of space, not rushing, not resisting, just going. And the final question remains, unanswered by NASA, unanswered by physics, unanswered by the universe itself. If everything is moving, if time has direction, if the universe does not end but transforms, then are we traveling toward a future we have never seen, or returning to a state we have forgotten?